Okay, so we're going to start chapter 5. Chapter 5 is about factoring. And in this chapter, there are going to be 3 basic skills that we're going to use. One of them is factoring by using the greatest common factor, which is what we're going to do on this video. The next one is factoring by grouping, which we're going to do in the next video. And then there's one called guess and check. There's a lot of different methods for this one. I'm going to use guess and check, which is sort of involving the inverse of FOIL to do that. And then the last thing that we're going to do then is we're going to put all 3 of those together on one problem. So, greatest common factor, factor by grouping, guess and check. Those are the 3 things that we need to know. Now all we need to know is which problems do we do those on. So not only am I going to talk about using the greatest common factor, I want to talk about what the problems look like and when I would actually use those. So, for section 5.1, here's a problem that I would use greatest common factoring on. And I know that by looking at the problem because I'm not going to be able to factor it by grouping. We'll talk about that. And it's not a trinomial because this one needs it to be a trinomial with an exception. And this one doesn't fit the exception. So I know that I'm going to use the greatest common factor. And the greatest common factor, remember, is the largest number that I can get that will go divide evenly into each one of the terms. So the largest number that I can find that will go into 12 and also go into 16 is 4. Here's where the students have trouble. Students have trouble with coming up with a number bigger than 12 or 16. And that would be the least common multiple. Multiples are bigger, factors are smaller. So it would never be bigger than 12. Okay, so then what do I need? I need to find the greatest common factor, and there it is, it's 4. So the greatest common factor, I would write this is 4 times 3x, and then I would write that as 4 times 4. So you can see that each one of them has a 4 in it. So I pick those 4s up, not the subtract sign, sorry. Pick those 4s up, and I stack them up together right here in front of my parentheses. So it's just like if you were turning in papers, everybody in the room would turn in their homework paper, and I would have a stack of homework papers in front of me. And then whatever's left on your desk is whatever was left from your greatest common factor. So that would be 3x and a minus sign and a 4. Okay, let's try that again. So the greatest common factor, I need a factor or a number no bigger than 2, because 2 is the smallest one here. No bigger than 2, or x, or y, or z, because those are the smallest ones here, that I know will divide evenly into 2xy and also into 8xy. So I notice that they both have an x in them, and I notice that I can also factor a 2. So then this would become 2x times y plus 2x times 4z. So again, everybody's passing in their 2 x's, and I'm making one stack of them. They're right there. So there's really more than one 2x there. There's a whole pile of them there waiting to be used for each one of the terms that are in here. So here, the greatest common factor, it's not bigger than x squared, it's not bigger than x. So there's an x there and there's an x there. So my greatest common factor is x. So that would be x times x plus x times 1. So I pile up my greatest common factor and put it in front of the parentheses or behind, I don't really care. And then that would have my leftover would be x plus 1. Last one for that. The greatest common factor can't be bigger than 12, actually. It can't be bigger than 6. Can't be bigger than x squared, actually. It can't be bigger than x. Can't be bigger than y for that. So a number that'll go into 6 and also go into 12 would be a 6 and an x and a y. Greatest common factor. So this is not the answer. This is a partial answer. The correct answer then would be 6xy times, now, what do I have to multiply this by to get this? So that would be a 2 and an x, and then a plus sign. And then I've got the 6 and the x and the y, but I need another y. Okay, so let's try that again. And I found this worksheet on edboost.org/worksheets for those of you who want to look it up. Greatest common factor. So the greatest common factor here, I'm looking for a number that will go into 72 and also go into 108. So I know the 2 will work. I don't know, is there a bigger number? Let's just use 2 and see what happens. So that would be 2 times 36x to the 5th minus 2 times 54. Okay, well there's another number that will work for 2 and 54 because they're both even. So I'm going to make that 2 times 18 x to the 5th minus 2 times 27. Well, 18 and 27 still have something in common. So that would be a 2 and a 2 and a 3 and a 6x to the 5th and a 2 and a 2 and a 3 and a 9. Well, those still have something in common, so that would be a 2 and a 2 and a 3 and a 3 and a 2x to the 5th, and then I've got a 2 and a 2 and a 3 and a 3 and a 3. Okay, make the long story short, some of you don't always find the greatest common factor at the beginning. I have to keep going until I find everything that there is. So there's a 2 in both of them, another 2 in both of them, there's a 3 in both of them, there's a 3 in both of them, and the rest of the stuff is what I'm going to continue to call my leftover. Final answer, 2 times 2 is 4, times 9 is 36, times 2x to the 5th minus 3. My greatest common factor happened to be 36. Let's try it again. Something like number 6 down here. 36, 54, 90. 36, 54, 90. I happen to know that 36, no, 9 will go into all of them. Let's try that one. So a 9, and this one has x to the 4th, this one has x squared, and this one has x. So the largest one I'm going to be able to get out of everywhere is x. This one has a y to the 3rd, a y to the 2nd, and a y. So the largest one I'm going to be able to get out of there is a y. So now, what's left over? So that would be 4. I need 4 of these, I only have 1, so that's x to the 3rd. I need 3 of these, I only have 1, so I'd need an extra 1. Sorry, extra squared. 9 times 6, and then that would be an x and a y. And 9 times 10. Am I done? Well, I have to keep looking and seeing if there's a greatest common factor. And actually 4, 6, and 10 do have a common factor of 2. So along with that 9xy, I'm going to try a 2 and see what happens. So that would give me 2x to the 3rd, y to the 2nd, minus 3xy plus 5. And now I notice that there isn't anything in this term that is in common with this one and also with that one. So my final answer then is 18xy times 2x cubed y squared minus 3xy, oops, plus 5. Okay, so that's what factoring by the greatest common factor looks like. There are going to be other videos for you to look at, so please let me know if you're having trouble with this.